This is an extra help video to explain what I mean by a perpendicular lever arm in a moment question. So in a moment question, we really only have one formula that the moment, which is a force that has a direction, it's about a point. Let's say I'm going to use point A. You're going to assume a direction. I'm going to assume clockwise as a direction is equal to the applied force that is on the object times the lever arm, which is the distance that is perpendicular from the applied force to the point of rotation A. So that's the formula that we need to work with. So the question is, how do you find that perpendicular distance? We know how to multiply F times D, but we don't know how to find D, that perpendicular distance. And the answer is, well, it depends. It depends on the shape. So if we have a basic case of a beam and that beam is loaded on the end, then it's easy. If this is the force down, then the perpendicular distance from, if this is point A of rotation, then the perpendicular distance is just going to be the length of that beam. But we don't want to get confused and always take that as the perpendicular distance, but that's d perpendicular, and you would just multiply magnitude of this force times this distance, perpendicular distance. However, it is a perpendicular distance. That was the answer because here's the perpendicular angle. Here's the 90 degrees. If that force were coming in at a different angle, if that force were coming in, say, at this angle, then what is the perpendicular distance? And it's a simple matter of following the same process each time. I need you to look at that force line. That force line is always going in one direction. I need you to extend that force line. And then I need you to make a line. And maybe it's even best if we insert a line. And we're going to insert a line from A, the point of rotation. So here's our line. And so you have to ask yourself, you've always extended your force line. You have to ask yourself, where does the line from A become perpendicular? And it no longer becomes perpendicular here because you see this angle that it's creating with the force, with the orange line, is not 90 degrees. So you just simply need to move this until it gets 90 degrees. So there it is at 90 degrees. Let's always draw our 90 degree angle in red. And now you ask yourself, well, what is the distance? Is this distance or is this distance? It is the one that, the line that will attach to the point of rotation A. So it is not this one over here. This is my perpendicular distance, is right here. How do you calculate that? Well, it's the geometry of whatever the situation is. In this case, you would probably know an angle up here. You would know angle theta, in which case you know angle theta here, in which case this is a 90. You would know alpha. And then you would be able to figure out the angle here, because you know theta. So, and then you know this is 90 degrees in here. So this would be 90 minus theta. In which case you would also know this angle up here. And you'd have to plug away because this applied force is applied at the top of the beam, which makes this a bit of a tricky question because you have this distance here. At any rate, if I put it on an angle like this, I'd probably apply it at the middle of the beam so that you don't have such difficult geometry. But once you get D perpendicular here, it's a simple matter of going through and using all of the geometry tools that you have available to you literally from Pythagorean's theorem and the fact that the sum of all sides of a triangle equal 180. So that's how you would find that distance. So now let's take a different shape then. So let's say, call that example A. Let's call this example B in case you want to email me and ask a specific question. Let's say this is the shape. And I'm going to rotate about the moment. Moment is going to rotate about the point A. And a force is going to be applied. Let's say we apply a force here. All right, applied a force right there. Then what I do is I take my orange line. I'm going to extend that force. There we go. And then I'm going to draw a line from the point of rotation. And I'm going to rotate this around, see when it's perpendicular to my orange line of force. Right now it's parallel to it. Now it's at an angle. Now it's at a bigger and bigger and bigger and bigger angle. And now it is perpendicular to my line of force. Here we see that this is perpendicular. So now we ask ourselves, what is the perpendicular distance then? Is it over here? Is it here? Or is it here? Is it there? Well, it's the one that touches the point of rotation A. So it's this one over here. So that's my perpendicular distance. Now, of course, you would need some geometry in the question. So this question would likely have some geometry. If I were giving you this question, I would probably give you, this would be known, a known value. And let's say this would, I would probably give you sort of an axis here. And I would say, I would give you this angle, for example. So now you have a hypotenuse and you have an angle, because that would be the same angle there, right? Just because of geometry. This angle would be the same as this angle here, which means that you would know this angle, and this angle is 90. So you can use Pythagorean's theorem to figure out what d perpendicular is in that case. We're just going to erase angles so that we know how to find that perpendicular distance. I have to put a new shape on here. There we go. All right. Here's an example where we have something rotating. Let's say it's a device that is hanging from a fixture. Let's say it's hanging from a fixture here with some sort of a cotter pin, and it has an interesting shape associated with it. And getting a little bit more practical, point of rotation is going to be A in here. And this one has a force that is something attached to it here. And pulling down, let's say, just being pulled down by gravity. But all you need to know is there's a force there in that direction. In this case, I would give you some angles. So let's just put in green what the angles would be. So I would let you know that that force is pulling straight down. If it's pulling down by gravity, then it's always pulling straight down to the bottom here. And I would also have to let you know what angle this device is sitting on. So you can establish sort of an XY axis. Let's say you want your, in questions where something's being pulled down by gravity, it's smart to make your XY axis align with gravity. So the Y axis aligns with gravity here. This could be X, this could be Y. And let's say I give you this angle in here. So this device is sitting at a 45-degree before it has this force applied to it. So in this case, we would assume that the rotation is going to be clockwise. And we need to figure out what is this perpendicular lever arm. So let's be consistent here. Excuse me. Let's be consistent and draw our force line with orange. And we just want to draw that line as big as possible on the page. Then we want to go from our point of rotation and we want to draw another line. So there's our other line. And we want this to intersect with the orange force line until it's perpendicular. Right now it is parallel with that force line. There we go, touching the force line, but it is not at a 90-degree angle. And I'm going to go through and wait until it's a 90-degree angle. There we go. Now I have a 90-degree angle. I'm right along that x-axis. So let's draw our angle in there. There's your 90-degree angle, perpendicular distance. And your perpendicular distance will be the side of that line that is that goes through the point of rotation A. So this must be my perpendicular distance. So in this case, and I would know my geometry because I have a 45-degree angle and I have 90-degree angle. So I just need to find out what that distance is. And so in this case, the moment about point A clockwise is going to be equal to just the scalar quantity. So not the vector quantity, but the scalar quantity in newtons of this force times the perpendicular distance in meters. So I hope this video helps you to figure out what the perpendicular distance is. We do need to apply some of our sort of geometry knowledge in mostly Pythagorean's theorem to figure out the value of that perpendicular distance. But it's very important to know the strategy of how to find what that distance is in order to get the magnitude of the moment correct.